Okay, so I think we can get started now. So hello and good afternoon. I see some familiar faces in here, but for those of you that don't know me, my name is Victor Guerrero, and I'm a senior analyst in the capital markets group here in 1010. So I've been with 1010 for 5 years and a half, so it's quite a long time. And yeah, I just want to welcome you to this presentation. And here, my goal in this presentation is to try to help you be more efficient using 1010 data, right? So one of the problems that we have seen with some of our clients, some of you guys, is that in some occasions you are not using 1010 in an optimal way, in the sense that 1010 is it's a full data analytics platform, right? And in some cases, some of you are just using it as a data warehouse, right? So basically, the data is loaded in there. You just run some aggregations here and there, maybe some G functions or something like that. But then the main analytics happen outside of 1010, like Python or R or something else. So the reason of this talk is to show you how you can start thinking about using 1010 in a more data analytics platform in which you can do end-to-end analysis, right? So some of the benefits for doing this are that you will be saving time, right? I mean, like you won't need to be downloading data outside of 1010. You won't need the need of using any external software, right? Because you can do everything in 1010. For those of you that were in my colleague Adam's Rothschild talk this morning, you saw that there are some advanced functionality in 1010. So, for example, the possibility of automating queries using the scheduler or something like that when a table updates, and then have all your analytics run like after that. That's a big advantage. But yeah, in general, the goal is just to show you, to give you some tips on how you can start thinking about like using 1010 in a different way, right? So the idea, and this is going to be the example that I'm going to be using. So I'm going to be using the Stacker dataset and the corresponding single-family dataset, right? So I'm pretty sure that a lot of you are familiar with these two datasets. For those of you that are not familiar, I'm just going to give a very high-level overview of the two datasets. So both of them are published by Freddie Mac. And Stacker is it represents unsecured bonds issued by Freddie Mac, in which the principal payments and the interest paid to the issuer, to the investor, depend on the credit performance of some loans that belong to a reference pool, right? So basically, whenever Freddie Mac issues a new of these one new of these deals, they also release the reference pool, and you can take a look at all the loans in that reference pool, right? So all of these loans have, actually, like Stacker started in 2013, so basically it's relatively recently, and the loans in each one of these Stacker deals are single-family, 30-year fixed rates, like mortgages. Right, and as a complement to this data set, they also published the single-family loan level performance. So this one is actually a historical data set. So it has almost 25 million different loans, and they go back to January 1999, all the way up to almost today. Right, so they update this data set on a quarterly basis, and they provide a lot of information on the historical performance of these loans. Right. You have information on the delinquencies, the losses, and actually for the losses you have information on where the losses are coming from, all the recoveries. So all of that it's a very complete data set. As I said, it's a huge data set. Right now it's something like 1.2 billion records, right? Stacker is not as big. It's only 80 million. But yeah, so it has its nuances too, like you have to load it on a monthly basis, right? But yeah, so the idea is that you can use the single-family loan-level dataset to build credit models so that you can predict performance of the Stacker deals, right? So that's the main goal of these of this dataset. And so how we can use this in 1010? So So the first thing to note is that we host the two data sets in 1010, so basically everything is in there, right? So if you want to link one table with the other, it's very easy, right? Very fast, so there's no need to worry about that. And then the idea that I'm going to suggest here is that, so you select one deal from Stacker, right? And look at the characteristics of the loans in the reference pool. And then you go to the single family, and you will try to find a set of loans, like some random sample of loans that resemble the characteristics of this Stacker pool, and then use those to predict the performance, right? So that's basically the idea at a very high level, right? And then once you have that sample, then you can basically compute whatever you want, right? You can build credit models, you can compute CPRs, right? You can do whatever you want. So that's the main idea. And so first, let me show you a couple of examples. So here, for example, we have one particular deal. This is the 14HQ03. It's a Stacker deal issued in 2014. Right, and here you can see the total CPR plotted against the loan age. In orange is the actual performance of the deal. In blue, you have the performance of the sample from the single family. Right, so it's not perfect. You actually wouldn't expect it to be perfect, right? But so the idea is that with the sample, you can get an idea of how like the deal is going to perform in the future, right? And then this is also similar. Is again total CPR. It's for the same deal, but now here I'm plotting against the refi incentive. This is only for loans that are between 18 and 36 months old. Right, but yeah, same idea. In orange, you have the actual performance of a Stacker, and in gray, you have the performance of the sample from the single family. Right. So now let's go a little bit deeper on how you can start doing this procedure. Right. So you have 11 different variables that you can use to determine which loans are similar to other loans. Right. So you have 5 variables that are categorical. Those are the state, the property type, the occupancy status, the number of units, the number of borrowers. And then you have 6 variables that are numerical: the FICO score, the loan-to-value, the debt-to-income, the original amount, the original term, and then the original interest rate, which for now I'm just going to talk about the original interest rate, but that's something that we're going to address in the next slide. But yeah, so the idea here is that you can basically look at the values of those 11 variables in the Stacker deal, and then go to the single family and try to find loans that are exactly the same, right? That match exactly all of those variables. That's doable. Obviously, the more accurate you are going to be, the less number of loans that you will be able to pick, right? The smaller the number of candidates that you will be able to pick from the single family. So you have to be careful with that. Also, there is another problem that I'm going to discuss later, which is the Lookahead bias, right? So the loans in the Stacker deal are probably going to be contained in the single family, right? So the single family basically contains all the loans, like a fixed rate, single family, 30-year. So the loans in the Stacker deal are also published in the single family. And so for the purpose of doing back testing, you shouldn't do that, right? So I'm going to address that in a second. But yeah, for now, these are the variables, right? And what I suggest is that instead of using the actual value for the numerical variables, you can bucket those variables, right? And this is very open-ended. I mean, like, I don't have a good solution for that. But yeah, for now, let's just mention that instead of using the actual values, you can just bucket them and match using the buckets, right? So, and here, you can imagine there is a trade-off. If you decide to use all the variables, as I mentioned, and you want to use the exact values for the numerical variables, you will get a very small, or potentially you will get a very small number of candidates in the single family. If you go the other way around, in which you can you select only a few variables, and the numerical variables you decide to bucket them in a way in which the buckets are really wide, then you will have a lot of candidates, but the loans are not going to be similar as the Stacker deal, right? So that's the trade-off. It's not straightforward how to decide on how to do this, but yeah. So I just want to mention that for now. And then I mentioned the original interest rate. So the problem when using the original interest rate per se is that like the single family data set starts in 99 when the interest rates were a lot higher than what they are right now. Right? So if you decide to use the original interest rate to do the match from the Stacker deal, as I said, like were issued from 2013. So interest rates have been relatively low and very stable since then. So you won't be able to basically match on any of the loans like basically issued before 2007 in the single family, right? So what I suggest here is that instead of using the original interest rate, you compute the spread at origination and use that to do the match, right? I mean, I'm not saying that this is the only way in which you can do it. Maybe it's not even the best way, but this is just one way to address the problem, right? So, and then for this particular talk, for the examples that I'm showing here in this presentation, I'm only selecting or only doing the match using 4 variables: the FICO score, the loan to value, the spread at origination, and the state, right? Again, like you could potentially use more or less, right? I'm also showing here how I'm bucketing the variables. So for the spread at origination, I'm basically making buckets of 25 basis points, starting from -50 to 200 basis points. For the FICO score, everything that is below 650 goes into one bucket, and then I just go in increments of 50 points. And for the loan to value, everything that is below 70 goes to one bucket, everything above 100 goes to one bucket, and then I just take increments of 10 points, right? So, and again, I mentioned a little bit about the Lookahead bias. And again, the problem with this is that if you don't take care of this, then basically your backtesting is going to look extremely good, right? Because we are basically using the same loans from the Stacker deal that are in the single family to predict the performance in the Stacker deal. So everything will look like almost perfect, right? So what I'm suggesting here is that you can try to solve this problem by once you create the cohorts, right, using the 4 variables that I'm suggesting you can use. You basically, let's say you pick a deal on the Stacker deal on the Stacker side. You have the 4 variables, and then you see for each one of the loans in the Stacker deal, like the cohort in which it goes. And let's say that for a particular cohort you have 3 loans. You look at the origination month for each one of the 3 months, and you take the lowest of them. And then on a single family, you do the same, and you basically take for each cohort the origination months that are even earlier than the lowest in here, right? So with that, you basically can be assured that you are not going to be picking the same loan. And again, there might be some other ways of doing it. This is just an example that I think that it solves the problem. And for now, I think that's what works, right? And now, once you have the cohorts, right? So you will have all the cohorts for the Stacker deal, all the cohorts in the single family. You are addressing already the Lookahead bias. Then the question is how to get the random sample, right? The random sample from the single family. And here the thing is that what you want to do is get a sample as big as possible that still resembles all the characteristics from the Stacker deal, right? So here I'm basically stating a procedure that you can do in 1010. So again, you don't need to go to R to generate random numbers or anything like that. Everything can be done in 1010 very easily. And so I'm going to explain this right now, and then we'll go over a numerical example so that it's a little bit more clear. But yeah, so for each cohort, you count the number of loans in the Stacker deal. You do the same for the single family, and then you took the ratio between the single family and the Stacker deal. So here, one important thing is that I'm assuming that if you do everything correctly, right, you will have more loans in the single family than you have in the Stacker deal. So this multiple is going to be a number that is greater than 1, right? Then what you do is that you look at that multiple across all the cohorts, and take the lowest one of them. So that's basically how much more loans you can pick from the original number of loans in the stacker deal. Right? And then you use that number to, you multiply it by the number of loans in a stacker. Right? You take again a ratio between that target and the number of loans in the single family. And that will define a fraction between 0 and 1, which is basically the probability that each loan in the single family cohorts will have to be selected. Right? And then the last thing is that you just need to generate a random number between 0 and 1. If the number is less than the target, then the loan gets included into the sample. If not, then you disregard that loan. And so as I said, like here is the numerical example. Right, so this is again for the same deal that we've been looking at, the 14 HQ03. So you have the 4 variables and the different buckets, right? So each one of them becomes a cohort. You can see that we have 2,258 different cohorts for the stacker deal. And as I said, like the first thing is that you count the number of loans in each one of the cohorts in a stacker. You do the same for the number of loans in the single family, right? So you get the multiple, which is just the ratio between the two of them. And then you go across all the rows, take the lowest multiple, in this case it's going to be 2.5, and multiply that by the number of loans in a stacker. Right? And then you just divide that number by the number of loans in the single family, and this is going to be your target fraction. Right? So for example, for the first row, so that particular cohort, each one of the 3,911 loans will have a probability of being selected of 0.0006, right? So then you just generate a random number, and then you'd select the sample, right? So it's very straightforward. Again, this is something that it's easy to do in 1010. You know, it's a lot of linking and stuff like that. But once you have it set up, it's very straightforward. And then here is an example on the performance, right? So it's same thing. So we have the CPR. And we have 10 different runs for so this is basically 10 different random samples, right? And so you can see how the performance changes a little bit for each one of these runs, which is what you would expect, right? So for this. And then another problem that we can have when you follow this approach, since we're looking at information from the single family that is historical, you basically cannot address, like in an easy way, house prices like in the future, right? So obviously there are two factors that influence, there are two factors that influence the behavior of the prepayments and credit performance of mortgages, house prices and interest rates, right? So, and what you would like to do is try to incorporate that in your analysis. This is not easy. This is actually, I think, a very complex problem, right? And again, you can probably come up with different ideas on how to address it. But for now, what I'm going to suggest is that you run different scenarios, right? So, for example, if you believe that, let's say that Freddie Mac issues a new deal today, you believe that interest rates and house prices are going to behave as they behave from 2010 to 2013, then just select a random sample from loans that were originated in 2010, right? Something like that. If you believe that we're going to have another crisis like 2007, 2008, then pick a random sample from 2006 or 2007. Right? So that's the idea. And here is basically what I'm describing, right? So here I'm showing the interest rates and the house prices. So house prices are measured by the national OFEO on the left-hand side. Interest rates are on the right-hand side, and they are measured by the 30-year PMMS. And this is basically for all the period in which you have information in the single family, right? So you can see that it's really hard because to try to solve this problem, in particular, if you think that let's say rates are going to go up and house prices are going to go up too, you don't have a scenario like that in here, right? So this approach kind of works, but it's not perfect, right? So that's why I'm saying that this is not an easy problem, but this is just an idea, right? And yeah, so these are a few examples right? It's the same CPR for the stacker deal in orange. Then in blue, you have the same performance. So what I was actually showing before is the single family vintage 2010, a sample from the single family from 2010. But you can see how different vintages behave in different ways, right? So, and also here you have same idea using the refinement incentive. So same thing. You basically, once you have the random sample, it doesn't matter like where it comes from. Like, you can just do whatever analysis you want to do. And then another interesting thing is that like you can actually calculate losses, right? Which is important for a stacker because the actual payments of interest and principal, of interest and principal are determined by the grade performance, right? So as I said, once you have the random sample, you can basically use any models or any of the other variables that you have in the single family to compute whatever you want. So in this case, as I said, they provide losses and at a very detailed level, so you can basically do this kind of charts, right? So you can see that for the single family vintage 2010, losses have been like really, really small. When you compare it with 2006, for example, like losses are relatively high, right? And here is a second idea. So how about instead of using the vintage to come up with like scenarios, here you compute the current LTV and the current rate incentive. Right, so you do that for all the loans in the stacker deal. You do that also for all the loans in the single family. And then you look at, or what you're trying to do is you're going to match using the origination variables. And let's say that you look at the current LTV 6 months, current LTV and current rate incentive 6 months after origination, right? So then you basically have 2 points, right? The origination and the 6 months. And obviously, you can do this procedure several times, right? I mean, you could look at origination 6 months, 12 months, 18 months, or all the way from origination to 1 year, matching every month. But yeah, this is just another idea on how you can try to address the interest rate and house prices environments. And yeah, here is an example, right? So in orange, you have the actual performance of the stacker deal. Then in dark blue, you have the performance using only origination, which is what we've seen before. And then in light blue, you have the performance using the current LTV and the current incentive rate, right? So it's a little bit different. Hard to tell which one is better, but yeah, so that's just an idea. And here is same thing. So we have the, this is against the current rate incentive. So here, the loans, or is the rate incentive for loans that are 18 to 36 months old. So yeah, again, like it's not exactly clear which one is better. I mean, probably from this chart, only using the origination variables looks better. But like that's something that can be used also for doing this kind of analysis. And then, as I've been saying, like once you have the sample, then you can basically use that random samples to create any kind of model that you want, right? And in particular, in 1010, we have several advanced modeling functions, from multiple linear regression to logistic PCA. We have cluster analysis functions too. We recently added the generalized linear models function, and we also host all the live linear library, which basically works for cluster analysis and logistic regression. So all of this is available to you in 1010. So you don't need to go to a statistical package like SAS or anything to do this kind of analysis. You can just do it in 1010, right? And yeah, with this, basically, we just reached the final of this talk. So, and the point that I want to get across is that you can basically do all your analytics in 1010, or most of them. I mean, I imagine that if you want to do something very specific, like a neural network, or like something really, really specific, then it probably won't be available in 1010. But for most of the other stuff, I think you can do it in 1010, and I also think that you should be doing it in 1010 because it's going to be faster, right? You will have the code in just one place. You will need to be downloading data and changing it from your computer to a server to another server or anything like that. Everything is in one place. And obviously, a procedure like this also works with any other data set, in particular for the CAS and the Fannie Mae single family. You can do exactly the same idea, right? But yeah, so with that, we have time for some questions. So nothing? Yeah.
So on the CAS versus stacker, is there any, I know that there's some nuances in things like deal name
Yeah.
And other fields that would differentiate those two. Do
Mhm.
you see anything, how much do you think you would have to modify code to run a Freddie versus a Fannie deal through a model that you could create in 1010?
You would have to modify it, but it's not that difficult, right? I mean, it's basically just changing the column names because the information that I'm using is pretty much the same. By the way, all the code is available. So Adam talked about a folder that he created, so my code is also under that folder. You should have access to it. But yeah, so I don't think it should be a big trouble, like changing the code. Yeah. Yep.
So when you do the sampling, do you sample by the vintage cohort and then do that like as a scenario analysis, or do you mix the sample with different vintage?
Yeah, so the question is, when I do the sample, do I sample using the vintage, or if I use the full data set? No, I sample by vintage, right? So I will have a sample from 2001, a sample from 2002, a sample from 2003, right? So
the modeling convention basically limited to the scenario that those vintage cohort experience.
yes, exactly. Hmm? Yeah.
Is there an add-on for index?
Nope. Yeah.
So Victor.
Yeah.
So when they do a new deal, so when do you know that actually they don't have the data in 2010?
Almost.
You're on this on a new deal.
So the new deals, yeah, almost immediately, I think.
Who's responsible for loading the don't have the data in 2010?
So we have a team of developers that are responsible for doing all the loading.
For example, right now there's a new deal. So is that don't have the data already in 2010?
I mean, it's going to take maybe one day, something like that. But yeah, it's going to be there really, really fast. Mm-hmm. Yeah.
Regarding the earlier question about sampling,
Mm-hmm.
what is the percentage of loans that are in the sample versus the actual staker deal?
So that's what the lowest multiple is telling you, basically, right? So in this case, it was 2.5. So that means that you are taking a sample that is 2.5 times the size of the, yeah, right?
There are a lot more loans in single family than staker.
Yeah, exactly. I mean, you could change that also, right? I mean, if you want to have the exact number of loans, then it actually becomes a lot simpler because.
But kind of probably just the idea like what is the objective of taking the sample versus the stakers, trying to predict the performance of the staker
Yeah.
based on the single family, which is a larger pool, much larger pool.
Mm-hmm.
But is the same family the same loans in both the staker and pension?
No, so that's why I'm taking into account the Lookahead bias,
Right.
right? So
Exclude, make sure it doesn't overlap.
exactly. Yeah, because that's something that if you try to do it in real time, then you won't have all that information, right? That's so.
So have you looked at how Freddie and actually Fannie does this exercise? They do this exercise as well. They map the new deal loans to the historical by vintage.
Mm-hmm.
And then essentially the one they want to show is the losses. They don't see because the deals are priced based on 10 CPR or so.
Mhm.
The market has been using that. But the one people care most about the credit risk.
Yeah.
So their mapping criteria is slightly different from yours. And also they're mapped to the vintage. So assuming for this new deal, if I map the loan to like say 2006
Mhm.
vintage, so how would they perform? So that's the access both Freddie and Fannie actually do. Would be interesting actually.
Oh, yeah, no, as I said, like I think it's very straightforward. I mean, like this procedure works for CAS too, right? So it's, I mean, I would just need to modify the code, but yeah, it's the idea is the same. Hmm?
I think the question was, you have to do the sampling by cohort. Like, how do you select which cohort is going to be weighted average as the final prediction?
No, yeah, that's not it doesn't have an easy answer, right? I mean, it's just trial and error, or whatever your assumptions are. So yeah, I don't think there is a very scientific way of just, like I'm going to do this procedure to select the vintage that is the best, right? Mm-hmm. Yep.
Last chart you showed, is it CDR or actual losses from the loans?
Those are actual losses.
There's some severity assumed, or?
No, they provide all that information. All of that is in there. So they tell you the unpaid balance at when the loan was removed. They tell you the net sales proceedings. They tell you the actual losses from taxes and insurance, recoveries for mortgage insurance, like everything. Yeah.
Delinquent interest.
Yeah, exactly. Everything is in there, so you don't have to make any assumptions. Mm-hmm.
Will you make this presentation available?
I think so. It should be available in a couple of days, or yeah. Yep.
Could you point back to the chart that had the current you were matching by LTV and refi incentive?
This one.
Yeah, when you're matching a current, so when you're saying current LTV, are you saying stacker loan deal LTV to prior to 2012 original LTVs? Or are you
No.
saying, are you implying current as in it's an updated LTV?
It's an updated LTV. Yeah,
And
exactly.
are you using HPI mapped to metros or something like that?
Yeah. So I try to go to the most granular level, right? So if we have an HPI for zip code, then or zip 3, yeah. So if not, then state. If not, then national. Mm-hmm.
So you're not matching month per month, right? The only difference between original and current is the time where you actually
just-
created that match.
Yeah, for this example, it's only 6 months, but there is nothing to prevent you from doing, matching like the first 6 months, for example. Right? I mean, you could do it and very easily also. Mm-hmm. Yep.
If you look at what a different way to select the population to model your previous and losses. So, for example, instead of finding similar loans in a bucketing scheme, trying to minimize the distance between your expected and actual CPR and CDR curve and having some algorithm select
Hmm.
minimize that error.
No, I haven't looked at that, but I think that's something that is certainly doable in 1010 also. Yeah, I mean, right now I don't have an answer for you, but yeah, I'm sure that that we can come up with an algorithm for that. Anyone else? No? All right. Well, thank you very much, and I really hope that this has been useful.